Hello, welcome back once again. Today we have another interesting geometry puzzle for Maths Olympiad. We're given a square and we have an inscribed semicircle inside this square. Our job is to find the area of this blue semicircle. So let's get started. Now, let us take note. This is the radius of this semicircle, right? So from this center here, this is the center of the semicircle, right? So let's draw this line from this center to this point, right over here. So this line here is also the radius of this semicircle. Now, let's draw this line from this point to this point to meet this line of the radius, and that is a perpendicular, right? Because it forms a 90 degrees angle right over there. Okay, so let us take note, this is the radius, right? Okay, so if this length right over here is 2, therefore this is 2. And again, this remaining length here will be r minus 2, since that total length of that line is the radius. Again, let us draw this line from this to this point. So this line is the radius, right? And again, let's draw this line to meet this and to form a perpendicular. Okay, awesome. Now, this is 1 unit, right? Therefore, this is going to be r minus 1 units. This is awesome. Now, let us take note of the following. Look at this angle here. Look at this angle here. And they both have the same angle from here. So that shows that these two right triangles are similar, right? Therefore, the base here is going to be r minus 1, corresponding with the one above this particular one. And again, this side here is going to be r minus 2, corresponding with the one at the lower side. Therefore, we're going to depend on one of these right triangles to solve this problem. Remember, we're going to use the Pythagoras theorem. Okay, so using the Pythagoras theorem, we have that r squared is going to be equal to r minus 2 squared plus r minus 1 squared. For here we get r squared is going to be equal to expand this binomial, we use the following algebraic identity. A minus b squared is equal to a squared minus 2ab plus b squared. So this is going to give us r squared minus 4r plus 4, and then plus r squared minus 2r plus 1. Now we know we can subtract r squared from both sides and get cancel, right? So here we have 0 is equal to r squared. So here negative 4r minus 2r is giving us negative 6r. And here 4 plus 1 right over here is giving us positive 5. So this equation is same as r squared minus 6r plus 5 is equal to 0. Now let's think about two numbers that the product will give us positive 5 and the sum will give us negative 6. These numbers are negative 5 and negative 1. Therefore, we'll write negative 6r as negative 5r minus r. And then plus 5, this is equal to 0. So factor out r from here to get r minus 5. And factor out negative 1 here to get r minus 5. This is equal to 0. From here, we get r minus 1 multiplied by r minus 5 is equal to 0. So when each of these is let equal 0, so we have the two solutions, r is equal to 1 or r is equal to 5. So what do we do to determine the correct value of r, since we have two solutions for r? Now, let us use one of the sides of this right triangle. So r minus 2, if r is equal to 1, then this is going to give us a negative value, and that's going to be very wrong because we are dealing with the sides or the lengths of a shape. And also r minus 1, if r is equal to 1, this will give us 0, and we know the length can be 0. Therefore, this is not our solution. R is equal to 5 is our solution. Now let us solve for the area of the semicircle. So the area of a semicircle is equal to half of the area of a circle, which is pi r squared over 2. So this is going to give us pi into bracket. R is 5 squared here divided by 2. Therefore, the required area is going to be equal to 25 pi divided by 2 square units. So this right over here is our solution. Thank you for watching. If you enjoyed this video, please kindly subscribe to this channel. Also like, comment, and share.